All right, ladies and gentlemen, let's see if we can get this thing to work out okay here today. So today we're going to talk about graphing sine and cosine. I'm not going to get into the tangent stuff today, and we're trying to stick with sine and cosine and do what we call a non-shifted graph. It's pretty straightforward. I've been kind of hinting towards where this stuff has all been going to when we were back in school. You know, it seems forever ago. But let's see if we can get this to look here. So what I'm going to do originally is I'm going to look at a cosine graph to start. So we all know cosine, since it comes first in the alphabet, is the x values. We also know that if we start at 0 and it goes all the way around the circle, that is one revolution. That's the period that we call that. So what we do for cosine graphs, to switch it from to an xy grid, we know that it starts at 0, and we know that it ends at 2 pi. Okay. From here, we know that halfway between 0 and 2 pi is 1 pi, and halfway between that is pi over 2, and then this would be at 3 pi over 2. It's convenient that those wind up being all of our quadrantal parts as we go through. So this is how we get our generic idea of what cosine looks like. So here's what we do. At 0, we know that cosine is at 1. At pi over 2, it's 0. At pi, it's at negative 1. At 3 pi over 2, it's back to 0. And then at 2 pi, it goes back to 1. So we get this curve, and I'm sorry I'm trying to draw this on the screen here. We get this curve that looks like this. So that's what the cosine graph, a generic y equals cosine of x. Now let me do one in sine. I'm going to do the same thing. Oops, change that. Let's do one in blue for sine. Okay. All right. So sine starts at 0. At pi over 2, it's at 1. At pi, it's back to 0. At 3 pi over 2, it's at negative 1. And then at 2 pi, it's back to 0. So you get this curve. Now, sine and cosine graphs, if you look at it closely, you might notice this. Let me see if I can grab this. They're the same graph, just shifted pi over 2, or 90 degrees shifted off of one another. So from here, we get these two generic setups. Oops, let's see if I can make this go again. It's kind of annoying that I have to retap these line parts. We get these two basic ideas. So what happens here is that our sine and cosine graphs have some basic things to them. Basically what happens is we're going to talk about as a sine of bx or a cosine b of x. This value of a that's up in front tells you the direction. Basically, if it's positive, it starts at 0 and then it moves up and does this. If it's negative, it would move down first and then up. Okay? We'll get to that as we come along through most of these later on. The absolute value of a always gives you the amplitude, what we call the amplitude. It's basically how high up the graph goes or how low it goes, the maximum and minimum values of the graph. This b value is used then to figure out what the period is. So for cosine and sine graphs, the period is always going to be found by taking 2 pi divided by b. I always put the absolute value of b in there. I don't believe we're going to have anything, in Algebra 2 you're never going to have to really worry about it, b values being negative. You'll get to the negative angle stuff like that when you get to pre-calc. So let's look at an example. Haha. Laugh, laugh. It's kind of funny. I will start here. So let's look at this one here. We have y equals 2 sine of x. And I'm going to change this just a little bit. I'm going to change this to y equals... Re-grab the picture. Change this. I'm going to change this to y equals 2 sine of, let's say, 4x. Okay? So what I normally like to do is that... that won't move. What I normally like to do is label out my parts first. So we know that our parts, what A, B, and what our A and B's are. So our A value is 2. Our B value is 4. So if my A is 2, that means my amplitude is 2. My B value helps me find my period, so it's going to be 2 pi over B, which is 4. So my period is pi over 2. Intercepts we'll worry about later. The max and min stuff will come across as well. So here's what we do. We know that it has to go up to 2, which means it has to go down to negative 2. We know that it starts at 0 and it ends at pi over 2. Okay? So even though it's ending at pi over 2, where this is its own period for this function, we have to figure out what is half of pi over 2. Well, half of pi over 2 is pi over 4. Half of pi over 4 is pi over 8. And then if you think about this, you have 1/8, 2/8. This becomes 3/8 as you're counting back. Now, as we go along to start looking at the graphing part of sine, remember, sine values always started at 0. So your sine value will always start at 0. Since our A value is a positive 2, that means it has to move at its first breakpoint. It moves up to the A value, and it goes back to 0. The opposite of A value, and then back to 0. And this gives us our sine curve. Now, for today, excuse me, for today, I want to make sure that you guys just label out just the way that this looks like on the graph that I showed you, and make sure you get all of your breakpoints, these guys. Because as we get into the shifting of these things, we're going to use the original breakpoints that we get here, and then we're going to add our H's and K's to it. So, not too bad, I hope. Let's try a cosine one then. And again, I'm going to change this just a little bit here. We'll say it is y equals... Oops. Let's say it's y equals... we'll go -3 cosine of 2x. We'll just do that. Okay. So now we know that we have an A value. Our A value is now -3. Our B value is 2. I apologize for my writing on the screen. This is really difficult. So that means your amplitude, remember, the amplitude is always the absolute value of A. So your amplitude is still going to be 3. The period is going to be 2 pi divided by 2, because that's our B value. So our period is at pi. And again, we'll come back to the intercept stuff later on. So once again, draw a little graph. We know it's got to go up to 3. We know it has to go down to 3. Okay. We know that it starts at 0. Or I'm sorry, this is 0, excuse me. And it ends at pi. And we just cut it in halves again. So this becomes pi over 2. This becomes pi over 4. And as you think about it, as you're cutting it back, this is 1/4, this is 2/4, here's 3/4, because this is at 4/4. Now, cosine graphs, remember, cosine always starts at whatever the A value is. So in this case, the A value is -3. So we plot it at -3. It goes to 0. It goes to the opposite of A, goes to 0, and it goes back to A. And this is what our cosine graphs look like. All right. Now, it seems really straightforward, which in fact it kind of is, but the trick here is remembering where things go, how things move. So when you have a cosine graph, when you're doing a cosine graph, its first spot is always going to be, it'll be at 0 and A, and then that's where you started at. When it's a sine graph, this should be an ordered pair. When it's a sine graph, it always starts at 0, 0. Sorry, forgot what I was talking about. Okay, so that's kind of the little trick when you're trying to figure out where do you start these things as you go through. Let's see. So let's throw a real funky one in there. So now I have 1/3 cosine pi x, which is fine, no big deal. So we'll start with the same thing, label out. Our A value is 1/3. Our B value is pi. So that means my amplitude is 1/3, and my period is going to be 2 pi over, 2 pi over pi, So it's just 2. Draw our little graph in. It goes up to 1/3, down to a -1/3, and it does not have to be scaled pretty. You just label it and say that's where it is, and it works. Here's my 0, and then it ends at 2. So this is 1. Here's 1/2, and then this would be 3/2. It's weird not putting a pi in there, but remember, cosine starts at your a value. A value is positive, so it starts at 1/3. We'll use green this time. Goes to 0, opposite of a, back to 0, and back to a. And there's your cosine graph. Okay. So I'm going to switch real quick to the Elmo, because I have the sheet I've been working on here. And this problem is the first one that I have on the worksheet for you guys that I made really fast. I just want to remind you of what it would look like. So the problem on the CUDA sheet looks like this. And what I want you to do is always label out your A value. Here is 2. Your B value is 3. So then when you start to write out, you know that your amplitude is 2. Your period is going to be 2 pi over b. So I wanted to make sure I showed you a weird one with a weird fraction, but it's okay. You guys know how to work with fractions. So we'll draw a little sheet or a little graph line like this. We know it has to go up to 2. It has to go down to -2. We just label it here and here. We know this has got to be 0, and at the very end is 2 pi over 3. So we start thinking about it. Well, what's half of 2 pi over 3? Well, half of 2 pi over 3 has to be 1 pi over 3. Well, what's half of 1 pi over 3? So basically you're thinking of as what is half of 1/3. So remember, when you're doing that, you're just multiplying fractions. You get 1/6. Okay? So this here is at pi over 6. So start counting them off in your head here. 1/6, 2/6, 3/6. Well, 3/6 pi is 3 over 6 is pi over 2. And then here's your 4/6, which is 2/3. So you're going to get some funky fractions from time to time, but they're not going to be anything crazy. It's nothing that you guys haven't been able to do before. So we have a sine graph, and sine values always start at 0. It goes to whatever the a value is. In this fact, our a value is positive. It goes up to 2, back to 0, the opposite of a, and then back to 0. And then we just kind of curve them through. Okay. So I need you guys to make sure you label these things legibly. If you need to write this out on a separate sheet of paper, go for it. Take a picture of it and email it back to me. That'd be fine. I set it up in the Go formative to give you guys a shot to see if it does work on the computer screen. Let me know if it's too much of a pain, and then in that case, just grab some paper and just draw it all out. For those of you guys that have really, really crummy handwriting, please take your time and space it out as you write this stuff through. And then hopefully this won't be so terrible bad. Give it a shot. As always, make sure you email me any questions or anything that you might have, and we'll go from there. So hope you guys are all doing well, and we'll talk with you guys later. Have a good one.